Hi everyone. As mentioned earlier, in this video we are going to look at addition and subtraction of rational expressions. And as before, when we defined rational expressions and functions, we're going to take an inspiration or motivation from rational numbers or fractions. So how do you subtract or add fractions? There are three possible scenarios. Right. The first scenario is that you have the exact same denominator. If you have the exact same denominator, then all you have to do is add or subtract the numerator. So this is the easy case. Now let's say your denominators are not the same. So what we are going to do is we are going to figure out a way how to make this into the easy case. Okay, so the goal now is going to be make the denominators same. Why? Because we already know how to add or subtract when the denominators are the same. To do that, we use one of the most popular tricks in math, which is we rewrite the number 1 as a fraction. So we notice that I have a 9 here and no 5. So if I multiply this by 5 over 5, 5 over 5 is 1. So I'm not making any change. Similarly, I multiply this by 9 over 9 and I'm not making any change because 9 over 9 is also 1. What I am doing in this process is I am making these denominators 45, because they're going to multiply across. So then I'm making them common. I'm making the denominators the same. So which becomes 10 over 45 minus 27 over 45, which I can then go ahead and subtract on the top as 10 minus 27 and negative 17 over 45. So by making the denominator the same, we reduced it to the easy case that we already know. Now even amongst the non-easy case, this is the easiest because we just looked at 9, 5 and we multiplied whatever was missing. Now sometimes that may not be the best possible goal. And for example, here I can multiply by 12 and 8 on the other side, but I also notice that 8 times 3 is 24 and 12 times 2 is 24, which means I can get to a much lower denominator which is common to both. So I can multiply and divide this by 3 and I can multiply divide this by 2 to get 21 over 24 plus 6 over 24, which becomes 27 over 24. And then I simplify that because 27 is 9 times 3 and 28 is 8 times 3, so it becomes 9 over 8. Now in this last process we went from C to A, right? Easier, making the denominator common. Now using the numbers 8 and 12, how we figured this number out to 24, this number has a special name. It's called the least common multiple, right? Or LCM. And here's how you find it. So to find LCM, you write the numbers as factors in factored form, right, as such. So for example, 8 is 2 times 2 times 2 and 12 is 2 times 2 times 3. Okay, so what you do is then you take out the highest powers of each factor. The highest powers of each factor. So that's why we picked all three 2's and just the one 3. And that gives me 2 times 2 times 2 times 3, which is 24. Okay, so for example, let's say it was 27 and 18, right? So 27 is 3 times 3 times 3, and this is 3 times 3 times 2. So I would take all 3 3's and the 2 to give me the LCM being 54. Okay, so we take the highest power of each factor. Now we can extend this to rational expressions, right? So let's do a subtraction. The rational expression, this is the easy case. Easy case because they already have a common denominator. Okay, x squared minus y squared is already a common denominator. So this comes out to x squared minus y squared. Then you have a 3y cubed minus 5x cubed. We distribute the negative, so it's negative 4y cubed plus 6x cubed. Now 6x cubed minus 5x cubed gives me x cubed, and 3 minus 4 is negative y cubed over x squared minus y squared. Now this is a difference of cube, which we recently learned can be factored as such, and the denominator is a difference of squares, which can be factored as such. And then, as before, we cancel what we can. Once we cancel, in the simplified form, this is x squared plus xy plus y squared over x plus y, which is the end product in the subtraction of these two expressions. So that's the easy case. Now, just as with the numbers, now we go on to the difficult case, and for the difficult case, we define something called, or we have to find something called the least common denominator, LCD, which is very much similar to finding the least common multiple. Okay. For example, here I'm trying to find the least common between these two. So first of all, remember it's always highest powers, right? So 10x squared is 2 times 5 times x squared, and 15x is 3 times 5 times x. So when I collect, the highest power of x is x squared, the highest power of 5 is 5, the highest power of 2 is 2, and the highest power of 3 is 3. So the LCD is 2, 3, 5 x squared, which comes out to 30x squared. Second example, 6x squared is 2 times 3 times x squared, and 9x is 3 squared times x. What's the highest power for x? X squared. Highest power for 3, 3 squared, and highest power for 2 is 2. So the LCD is 2 times 3 squared times x squared, which is 2 times 9 times x squared, which is 18x squared. Now let's move on to slightly more complicated, in which you have to do some factoring. So this is 7x times x plus 4. This is, if you look at it carefully, that's 4 squared, and this is 2 times 4. So this is actually x plus 4 whole squared. So when you're writing the LCD now, the highest power of 7 is this, highest power of x is x, but the highest power of x plus 4 is x plus 4 squared. So the LCD is 7 times x plus 4 to the power 2. This is why you have to factor it completely before you can compare, because it has to be products of things. This one, just like the first one, factors as 5x, x plus 3, and this is x plus 3 whole squared. So that the LCD is now 5 and an x plus 3 squared. So this is 5x times x plus 3 whole squared. So these were examples where we just found the LCD using a method which is parallel to finding LCM. So you factor everything out and you collect the highest powers. Now I'm going to end this video here, and in the next video, once we have the LCD, what is the next step? So go back here. Once you had your LCM, the next step was to multiply, divide to make sure that the denominators are same, and then you combine them because they have the exact same denominator. So that's what we're going to do in the next video. We're going to look at how to combine these after having figured out the LCD. Okay, that's it for this video. Thank you.